All right, welcome to the second screencast for Chapter 8. This screencast, we are going to talk about production. So in the last screencast, we talked about economic cost and how that differs from an accounting cost. Now we're going to turn to a firm's producing things, taking those inputs and turning them into outputs and selling them at market rates. All right. So inputs are resources that are used in the production process. They're also called, a little bit fancier term by a lot of economists, they are the factors of production. All right, so they are labor and capital, and sometimes M for materials. Sometimes you'll see, if you're reading other books or you're looking online, sometimes they call it raw materials or natural resources. Sometimes land is included in this, but for us in this book, we're mainly going to just use labor, capital, and sometimes we'll have this M material. So those are the inputs into the production process. So the firm hires labor, it buys or rents capital, it takes those raw materials, and it turns them into their output, all right? So the output is the product that the firm creates, all right? So inputs, capital and labor, the firm puts them into their production process, whatever that is. Right now it's literally a black box here for us, and they get outputs, which are gonna label output by Q, capital gets a K, and labor gets an L. Why not C? Well, in a lot of econ notation, C already C was already taken, but also capital, Marx's Das Kapital was an econ textbook at one point a long time ago, Marx and Engels, and so the K, I think it comes from that, from capital there, but I think it's mainly because C was already taken for something else in a lot of econ models. So a production function is that black box, all right? The production function is the thing that takes the inputs, puts them into the production process, and then it turns them into outputs, all right? So it shows us the exact relationship between inputs and outputs. So you tell me how much labor, how much capital, how much in materials to put in, and the production function, it's a mathematical function, will say, we'll add them all up, or multiply the labor by 2, and whatever it is, combine those things in the way of the firm's production function, and it outputs how much quantity they can produce, all right? So to create output, the owner has to decide, how many do I want to put in? So mathematically, it looks like this. So this just means the quantity that the firm produces is some function of capital and labor. This notation means that the quantity of output equals some sort of function of capital and labor. So this notation is a stand-in for, I'm not telling you exactly what it looks like right now because I just want to generically talk about all production functions, right? So all production functions are a function of K and L. But sometimes this notation can be confusing, and it was confusing for me when I sat where you sat, and even up until I was in grad school, I didn't quite know what this meant. It just means a generic function. So what we mean is it could look like K plus L, or Q could be K times L, or maybe it's K to the 1/2 times L to the 1/2, or maybe it's K plus L to the 1/2. All of these are possible production functions, okay? But right now, we just want to talk generically about all production functions. So I don't want to give a specific form. I don't want to tell you how the labor and capital really combine right now. I just want to give you a generic stand-in so I can talk about it. And that's what this F of KL. It means F just means some generic function, and the inputs into it are K and L. Okay? So that's what this means. And when I put K and L in, F does whatever it does depending on the particular F, and then it spits out the quantity. All right. So quantity of output is a function of capital input and labor input. All right. So the marginal product of a firm is going to be the change in output divided by the change in input. All right. So we have two different marginal products. All right. The marginal product of labor and the marginal product of capital. All right. So they look like this. So the marginal product of labor is how much did the quantity go up? What is the change in quantity when I added some more or I changed labor? So I put some more labor in. I changed labor. How does quantity change? This one says I change capital. I buy more machines. I sell machines. However I change capital, how does that change the quantity I can produce? All right. Those are the marginal products of labor and the marginal products of capital. Okay. So, and that's mathematically what it looks like. All right. So here's an example of what this might look like for a particular firm. And here they're hiring workers. So what I'm going to look at here is how does the quantity of meals I can serve per hour change as I hire more workers. All right. And that's going to be the marginal product of labor. All right. So as I go from 0 workers to 1 worker, I go from 0 meals served to 5. That means the marginal product of the first worker is 5. All right. Then I add a second worker. All right. So what is the marginal product of the second worker? Where my total output goes up to 15. So from 5 to 15, the marginal product, the difference between those, how much Q went up when I moved L up by 1 is 10. So the marginal product of labor for the second worker is 10. The marginal product of labor for the third worker, I go from 15 output, a Q of 15, to a Q of 30. All right. So the marginal product of the third worker is from 15 to 30, it's 15. All right. So I'm getting more and more marginal product for each worker I add. Right. The first worker made it go up to 5. The second worker went up 10. Right. We went from 5 to 15. The third worker added 15 more. I went from 15 to 30. All right. So the marginal product is increasing as I add more workers. Here, when I add the fourth worker, it still goes up. I still get more output, right? I went from 30 to 42, but it only went up by 12. So the marginal product of labor is now falling as I add more workers, okay? And down here at when I add the ninth worker, I go from producing 67 to actually producing 63. I added so many workers that something happened and I have a negative marginal product of labor. All right, that's probably, as you can guess, a bad thing. So here we're going to graph pretty much what we saw on the last chart. So we're going to have the total product, which is just going to be what is Q, how much output are we producing as we add more and more workers. And then we're going to have the marginal product, all right, which is going to say how much did it go up when I added one more worker. All right, so the top graph here is going to be total output, and the bottom is going to be the marginal product of labor. All right, and we're going to be adding workers as we move across. All right, so here we're going to have the axis is going to be at 0 because we're never going to produce negative amounts of goods. But as we saw in the last graph, it may be the case that adding more workers eventually leads to Q going down instead of going up. All right, so that the top graph is just what is Q overall. The second is, as we added the next worker, how much did Q go up or down? Okay, it's the same thing that was on the chart. We're just doing it here graphically. So total output here looks like this for that last graph. So it went up and then it kind of flattened out, the total product. As we kept adding workers, there was some point where Q stopped going up and it maybe even went down a little. All right. Down here, we can see this is what the marginal product of labor looks like. All right. So at first, we kept getting more and more Q, increasing Q. So notice this function is increasing at an increasing rate. As we add workers, we don't just get like a bump of 5. We got a bump of 5 for the first worker, but then for the second worker, we got a bump of 10, right? The first worker, we got a bump of 5. Second worker, a bump of 5. Then we got a bump of 10, all right, to go to 15. So that's increasing at an increasing rate. But then, as we saw in the chart, as we kept adding workers, Q still went up, right? The overall amount you're producing still goes up. I hire the worker, I get more meals served, but their marginal product, the increase that I get in Q, was a little less. All right, it went back down, okay? So this typically is what we see when we look at total output and then marginal product, all right? We see increasing at the beginning, and then it sort of flattens out. And notice, once this goes negative here, it starts to pull the total output down. I keep adding workers, I'm getting less Q than I was before. All right. So in this range, again, to sum up, in this range, we were getting, as we added workers, it was increasing at an increasing rate. We got 5, then we got 10, then we got 15, right, on the chart. But then we hit a point where adding workers, while still giving us more Q, actually the amount more that we got was less than the worker before. All right. So maybe we're getting crowding or something like that. All right. And then eventually we get to a point where if we add any more workers, we actually hurt the amount of output and it starts to pull total output down. So we call this diminishing marginal product. All right. So successive increases in an input eventually cause output to increase at slower and slower rates. All right. Assuming capital is fixed, we eventually get to a point where a new worker adds less output than the previous worker. All right. Because at the restaurant example, we don't have enough machines to go around. We don't have enough grill area. We don't have enough tables. We don't have enough room to keep adding workers and getting positive amounts of output. All right. So we get diminishing marginal product, and then eventually we get negative marginal product, where we're actually decreasing the total amount of output. All right. So in our example, laborer 3 increased output by 15. Laborer 4 increased output by 12. The fifth person increased it by only 10 more. We're still getting more output, so we still may want to hire those people, but the added benefit of them is shrinking. All right. So why does this happen? All right. Well, think about the fact that your capital is fixed. All right. There are too many cooks in the kitchen, right? They're crowding, they're bumping into one another. The extra workers eventually have to work less. Eventually, the next worker has less work to do, and they won't be able to add as much to overall output. Not because they're less skilled. We're assuming in this model everyone has the same skills, but because we don't have enough capital for them to use. All right. With a very large amount of labor, new workers might actually interfere with the existing workers and slow them down, meaning negative marginal product. Okay. So here's a little example I want to end with here. So we're going to think about diminishing marginal product of labor, and we're going to use garbage collection as an example. We're going to use garbage collection that has the guys that ride on the back of the truck. I don't know, in my neighborhood, they bring by this little machine that the guy doesn't even have to get out of the truck. This example requires the guys who ride on the back of the truck. All right, so that's our fixed input, is the truck. We only have one truck. But we have a variable input, meaning we can use more or less of it as we see fit, all right? And that's going to be labor. And those are the workers on the truck. Our output is trash cans picked up, okay? So here we go with our garbage truck, all right? Very skillfully drawn garbage truck, all right? So let's add the first worker, all right? So that's probably positive, right? The truck can't move unless we hire the first person. All right. So he goes out and he collects garbage. It's slow going though, right? Because he has to park the truck, get out, go get all the cans, bring the trash up, and throw it into the back of the truck. All right. So we decide, well, it's probably going to be a positive marginal product. It's probably going to give us a good return if we add another person to ride on the back. All right. And that works out well. So we get a positive marginal product of labor, and it's probably even increasing at an increasing rate. They can probably do more so say the first guy was picking up 100 trash cans, they may be able to pick up like 300 now. A lot more, right? Then we decide to add a third person. This might even be better, all right? Because one guy can get one side of the street while the other guy gets the other side of the street, and we can go really fast. So we went from 100 trash cans to 300 trash cans. Maybe they can now go, by adding just one more person, like to 600. All right, so the first marginal product would have been 200 from 100 to 300. I'm sorry, the first marginal product was higher than the first guy, from 0 to 100. The second guy took us from 100 to 300, a marginal product of 200. This third guy took us from 300 to 600. His marginal product was like 300, all right? So again, we're increasing at an increasing rate the total Q, the total amount of output, the total trash cans we can pick up, okay? Let's hire another guy. So this is probably, so the guy can give him directions or something, stay on the radio with the home base. So now we're saying that's probably going to help, but not nearly as much as it helped to get the second guy on the back of the truck. So maybe we go up to, say, 800, right? So his marginal product's only 200 now, all right? So now we have that diminishing marginal product. And then let's add another guy. Well, this is, I don't know if there's much for this guy to do. Maybe he can yell at kids, watch out for stray dogs. I'm not sure what he's going to do exactly, but he's not really going to buy us a whole lot more output, all right? And then if we keep adding people, this guy gets left behind, some dude falls in, another guy falls in. Now we've got negative marginal product for labor, all right? Things, they're actually making it worse, okay? All right, so I hope that kind of helped you understand. It's kind of tricky. Go back to those graphs. The increasing at an increasing rate as we add people, as long as their marginal product is positive and getting bigger, increasing marginal product. Eventually we get decreasing marginal product, and that means the curve keeps going up, but now it's going up not quite as fast, at a decreasing rate, we would say. And then eventually adding people turns the whole thing negative. Marginal product goes below 0.